All right, 22 I have up here on the board. One of the things that, it's a much lengthier process using a 3x3. One of the things I suggest is when you're missing variables, line them up. So I know on the paper it has negative 4x plus 7z equals 26. Notice I left a space for y, so I've lined up my x's. Then I've got my y's lined up, and I've got that space for the missing z in the third one. Because what that's going to mean is when I go to my base determinant, that's going to put zeros in those two places. Okay, so I've written my base determinant here. I did my first two columns. There's my calculations. Negative 732. d sub x would be the answer is 26, 58, 23, or replacing that x column. Again, I rewrote the first two columns, calculated negative 29, 28. D subscript y, those answer values, place the y column. Calculated, I got negative 732. And then those answers replace the z column for d subscript z, rewrote, and then calculated, and I got negative 4392. Okay. Again, long process writing out all the 3x3s. So I've got it up here. You can pause, look at the different values, rewind if need be. But let's finish this guy up here. Once I've got all my values, I know x would be the negative 29, 28 over negative 732. The y would be negative 732 over negative 732. And the z would be negative 4392 over negative 732. So those values would be, let's see, we got a 4 for x, a 1 for y, and a 6 for z. All right. 23, 24, 25 are some addition, subtraction with some scalar multiples. So on 23, it's asking me for 2a plus b. So the first thing I want to do is figure out what 2a is. So 2 times the a matrix would be 2, 6, 4, 10. And then plus the b matrix, 0, 4, negative 1, 6, would give me 2, 10. 6 and 4 is 10. 4 and negative 1 is 3. And 16. Right? So if I see a scalar, in other words, at 2 times a, something being multiplied, I want to multiply first, and then I can add or subtract what I'm asked to do. Okay. So on 24, I'm asked to do c minus 3d. So I'm just going to write c down, 1, negative 3, 2, minus, and then 3 times d would be negative 3, 9, negative 6. Now I can subtract them. So 1 minus negative 3 is 4. Negative 3 minus 9 is negative 12. And 2 minus negative 6 is 8. The last one in this part, 25, asked me to do negative 2a plus 4b. Okay. So 25, negative 2a plus 4b. So that would be negative 2 times the a matrix would be negative 4, positive 2, negative 14, negative 18, plus 4 times the b matrix would be 20, negative 12, 16, and 28. Now I can add them. So when I add them, I'd have 16, negative 10, 2, and 10. Those pieces there. Right. The next set is some multiplication. When I'm multiplying matrices, 26 here, I need to remember it's row times column. So I'm going to have a 2 by 2 times a 2 by 2, so I can do it. And I'm going to have, for the first part, negative 2 times negative 2 plus 3 times negative 1, row, column. Then negative 2 times 0 plus 3 times 5. First row, second column. Go to my second row, 2 times negative 2 plus 2 times negative 1. And then 2 times 0 plus 2 times 5. And that would give me, let's see, that'd be negative, excuse me, that's positive 4. Minus 3 is 1. 0 and 15 is 15. Negative 4, negative 2 is negative 6. And 10, that piece. 27. I've got a 2 by 3 times a 3 by 2. So I'm going to have 1 times 3 plus 3 times negative 1 plus negative 1 times 0. So 1 times 3 is 3. 3 and negative 1 is negative 3. So 3 minus 3 is 0, and 0 is 0. Then I've got 1 times 0. That's 0. 3 times 1 is 3. And then negative 1 times 3 is negative 3. So that's 0, 3, and negative 3 is 0. 2 times 3 is 6. That's 0. That's 0. So 6. 2 times 0 is 0. 0 times 1 is 0. 3 times 3 is 9. Giving me that answer for 27. The last multiplying one here, 28. All right, we have a 2 by 3 times a 3 by 1. So I'm going to have negative 4 times 5 is negative 20. Negative 5 times 5 is negative 25, so that'd be negative 45. Plus 18 would be negative 27. Then negative 5 times 5 is negative 25. There's negative 35, so that would be negative 60. And negative 6 is negative 66, giving me my 2 by 1 solution there. Inverse of a 2 by 2. So for 29, I'm just going to call it A. A would be negative 2, 4, 4, negative 4. Right? So A inverse would be 1 divided by the determinant. So back to our 2 by 2 determinant, this would be 8 minus 16 is negative 8 times these two switch places, so the negative 4, negative 2 switch places, the other two change signs. So now I'm distributing that negative 1/8 times that matrix, which would give me a positive 1/2, or the 4/8, so there's 1/2, positive half, positive half, and positive fourth. 30, I'll just call this one B. 4, 4, 1, negative 5. So B inverse, 1 divided by the determinant. So negative 20 minus 4, negative 24. And then these two switch places. I'm at negative 5 here, 4 there. And these two switch signs. So negative 1, negative 4. So then that's going to give me a positive 5/24 when I distribute. Positive 1/6 because I have 4/24, which reduces. Positive 1/24. And negative 1/6 on that. All right. 31 and 32, using an inverse to solve a system. If we take the inverse, the way we can solve a system is if we take the inverse and multiply it by the answer matrix, that's going to give us the solution. So my inverse on 31 is, I'm given is negative 2, 4, negative 1, 3, negative 5, 2, negative 1, 2, negative 1. So I'm given the inverse of this 3 by 3. I'm given that piece. If I multiply that inverse times the answer matrix, which is the negative 3, negative 7, 6, that will give me my solutions for X, Y, and Z. So again, I'm multiplying row times column. So I get negative 2 times negative, that's 6. There's negative 28, so 6 minus 28 is negative 22. Minus 6 is negative 28. 3 times negative 3 is negative 9. Let's see, that'd be 35. So negative 9 and 35 is 26. And 12, 38. Then we would have positive 3, negative 14. So 3 minus 14 is negative 11. And negative 6 is negative 17. There's a solution to my system. This is the X, that's the Y, that's the Z. So again, 32, same idea. I'm taking the inverse I'm given, which is 1, negative 1, negative 1, negative 3, 5, 2, 2, negative 3, negative 1. And I'm multiplying that by my answer matrix, 10, negative 7, negative 5. And that's going to produce my X, my Y, my Z. Oh, top number. Let's see, that'd be 10, plus 7 is 17, plus 5 is 22. Negative 30. Negative 35, so that'd be negative 65, and then negative 10, negative 75, and then 20, 21 is 41, and 5 is 46. And again, those are my values for X, Y, and Z. So you remember, multiply my inverse matrix that I'm given times the answer matrix. All right, partial fraction decomposition. So on 33, it's not factored. So one of the things I want to do when I see that denominator not factored, Let's go ahead and factor it. So this would be x over x minus 5, x minus 6. So now I know it'll be a over x minus 5 plus b over x minus 6. It doesn't matter what order my factors are in. Okay. So here I would have common denominator, x minus 5, x minus 6. So I have a times x minus 6, b times x minus 5. And so since these two fractions are equal and they have the same denominator, I know x would be a times x minus 6 plus b times x minus 5. Now I can work to solve. I'm going to let x equal 5. So that would be 5 equals negative a. That's 0. So a would be negative 5. I'll let x equal 6. So 6 would be, that's 0. 6 would be b. There's my a and b value. So then my answer would be negative 5 over x minus 5 plus 6 over x minus 6. And it wouldn't matter which one of those two fractions were written first. 34 is already factored. Matter of fact, 34, 35, 36 are all already factored. So I know what the denominators are going to be. So what I know is on 34, I know I'm going to have a over x minus 4 plus b over x minus 5. There's my common denominator. X minus 4, x minus 5. So that means a would have to be multiplied by x minus 5, b by x minus 4, and I know this equals the numerator given, x minus 9. Then I can substitute my values to solve for a and b. I'm going to let x be 4. So 4 minus 9 is negative 5. 4 minus 5 is negative 1, so negative a, and that's 0. So a is positive 5. And I'm going to let x be 5, again, because that's what's zeroing this out. So 5 minus 9 is negative 4. That's 0. 5 minus 4 is b, so there's my b. And then I just rewrite my fractions, so I know this guy right here is the 5. And that one's the negative 4. $35, we have three fractions. It's not changing how the setup will be. I'm just going to have an A, B, and a C. So 35, I know I've got A over x plus 8, B over x plus 2, C over x plus 11, and I'm just writing it in the order that I see the factors. Okay? So once I get my common denominator, which is going to be the original denominator, those three, I know that A has to be multiplied by x plus 2 and x plus 11, B by x plus 8 and x plus 11, and then C by the x plus 8 and x plus 2. So C times x plus 8, x plus 2. And I know that equals the 12x squared plus 162x plus 384. 12x squared plus 162x plus, squeeze that in there, 384. I have a large value there. That's okay though. Okay. I'm going to let x be my domain restrictions. So I'm going to let x be negative 8. So let's see, I'm going to go 12 times negative 8 squared plus 162 times negative 8. I'm just substituting negative 8 in for x. So I've got negative 144. All right, and see, negative 8 plus 2 is negative 6. Then that would be negative 8 plus 11 is 3. So I got negative 6 times 3 is negative 18a, which means a would be 8. Got the a value. Now I'm going to let x be negative 2. Notice when I did that the negative a, excuse me, I didn't worry about these two because that's 0. 0 times anything is 0. That's 0. 0 times that's going to be 0. X is negative 2. Right, so on the left side, 12 times negative 2 squared plus 162 times negative 2 plus 384. Give me 108. Right, negative 2 will zero out this term. It'll zero out the c. And right here, negative 2 plus 8 is 6. Negative 2 plus 11 is 9, so that would be 54b. So b would be 2. I've got a and b. The last one, I'll let x be negative 11. And so I've got 12 times negative 11 squared plus 162 times negative 11 plus 384. I got a 54 equals. And a negative 11 will zero out this term and this term. Negative 11 plus 8 is negative 3. And that would be negative 9, so that would be positive 27c. And so c would be 2. And then I can go back, rewrite my fractions. That's an 8. That's a 2. And that's a 2. And I've got my partial fraction decomp. 36, I've got a repeated factor in there. That x, I should have read that right, x plus 1 squared. So with that x plus 1 squared, I know I'm going to have an a over x plus 2, a b over x plus 1, and a c over x plus 1 squared. So when we had that repeater, we had to count up to it. Okay. So when I get my common denominator, it would be a times x plus 1 squared, b times x plus 2, and the other x plus 1, and c times x plus 2. And my numerator that it equals to is 6x squared plus 16x plus 9. So I've got two domain restrictions, the negative 1 and the negative 2. So I'm just going to say x equals negative 1. Well, if x equals negative 1, let's see, I would have 6. 6 minus 16 is negative 10. Plus 9 is negative 1 equals, that's 0, that's 0, c. I've got c. Because negative 1 plus 2 is just 1. If x equals negative 2. Alright, so we have 24 minus 32 is negative 8 plus 9 is 1. So that's 0, that term's 0. Negative 2 plus 1 is negative 1, squared's 1, so a is 1. And then I don't have another domain restriction, but this is where we can just pick any value we want. I'm always going to pick a nice easy value that I haven't used. I haven't used 0, might as well use it now. If I let x be 0, I'd have a 9 on the left side. 0 plus 1 is 1, so that would just be 1 squared, it's just a. Here, this would be 2 times 1 is 2, so plus 2b. And here, 2c. But I already know a and c. So 9 is 1 plus 2b. And then minus 2, because I had c is negative 1. So 9 would be 2b minus 1. And that would give me a b is 5. Add my 1's 10. Divided by 2 is 5. And there's my three fractions. I've got a is 1, b is 5, and c is negative 1. On the last problem, I need to factor that denominator. So I can factor an x out first. So I'm looking at that denominator and I'm going, all right, I can take an x out. I'm going to go ahead and do that. So I'd have x plus 3 over x times x squared minus 2x plus 1. Wait a minute, that's x times x minus 1, x minus 1. Well, that's x times x minus 1 squared. So I'm looking at, again, another repeater there. So I'm going to have a over x, b over x minus 1, c over x minus 1 squared. Common denominator. Get my numerator set up so I know x plus 3, this numerator is going to have to equal a times x minus 1 squared, b times x and the other x minus 1, and then c times x. I'm going to let x be 0. 0 and 1 are my domain restrictions. So that's 3 equals a, because negative 1 squared is 1. That's 0, that's 0, so I got a. X is 1, so I have 4 on the left. 0, 0, c, I got c. And then I don't have another domain restriction, so I need to let x, again, be anything I want. I want to pick a nice small number. I'm going to pick 2. I'm selecting 2 because I kind of see, hey, 2 minus 1 is 1. That's going to give me something easy to work with. Okay. So 2 plus 3 is 5. That would be A. That's 1 times 2 is 2B. And then 2C. So 5 equals, I have A is 3 already. Plus 2B. And if C is 4, that would be plus 8. So I've got 5 equals 2B plus 11. Subtract my 11s, negative 6 is 2b, b then is negative 3, and I've got my values. I've got a 3 for a, 4 for c, and a negative 3 for b, and there's my 3 fractions for my partial fraction decomposition.